Everyone, welcome to our first class for trig. Hopefully, this video should be a fairly quick review for everyone, and yeah, there'll be more that follow up with the new stuff. So let's jump right into what we have here. You probably remember when we're talking about triangles, all of the angles inside of a triangle, they add up to 180 degrees. And right angle triangles are what we're going to be talking about with SOHCAHTOA, which should be, like I said, review. So in a right angle triangle, one of our angles is 90 degrees. And our hypotenuse is the longest side. The longest side in the triangle, and it's always right across from that 90-degree angle that we were talking about. What's going to be important moving forward is how we actually label the triangles and the convention we're going to use there. So we're going to use lowercase letters for the sides. And then we're also going to use capital letters for our angles that go across from those sides. Okay, so in this example here, I've got a capital C. There's my right angle across from lowercase c as the side. So angle B and straight across is side B. Don't ever assume that a triangle is a right angle triangle in this unit unless it has this little square in the corner. Moving forward with trig, our hypotenuse is always going to be the same, or in this case, the hypotenuse, because it's awesome. But the opposite and adjacent sides of our triangle change depending on where we're standing. So for instance, here, we're looking at x. So this side is opposite the angle that we're looking at, and this side is adjacent. If I was standing in this corner over here, all of a sudden, I would have side B being my opposite and side A being my adjacent. So it's just something to watch out for moving forward, making sure we're standing in the corner, figuring out which side is which when we want to use SOHCAHTOA ratios. So sine, cos, and tan, or sine, cosine, and tangent, as they're actually spelt out, they're really just ratios. They're a fraction of taking your numerator to be one side length, and your denominator is going to be another side length. And depending which ratio we're using, sine, cos, or tan, that's going to decide what goes into your fraction. Okay, so a reminder, if you haven't heard SOHCAHTOA before or wondering what this word is that I'm saying, sine is opposite over hypotenuse. Cosine of an angle is the adjacent over the hypotenuse. And tangent of an angle is opposite over adjacent. What these ratios are saying is that for any triangle where I've got all of the angles the same, so let's say this angle and this angle I'm going to be talking about, the sine, cos, and tan of this angle in the big triangle is going to be the exact same value as sine, cos, and tan of this angle in the little triangle, because we're talking about a ratio. So I know some of you are going to be pretty excited about this page. These big triangles that I've got on the top of the page are our little shortcut triangles. And so the way they work, you just cover up the value that you're looking for. So for instance, let's say we want to look at cosine. I'm going to try to find the adjacent side in my triangle. I cover up my adjacent. Whoops, that's not what I meant. Undo. Oh my god, oh my god. Okay, there we go. I'm covering up the adjacent, and I have cosine times hypotenuse, and that'll give me my adjacent value. If I needed to use cosine and I wanted to try to find the adjacent, or sorry, if I wanted to try to find the hypotenuse, cover it up, I'm going to do adjacent divided by cosine. Another thing to note with all of these, all of those are going to give me just the ratio value. I can't do this and then figure out theta. If I want to actually find out the angle, we have to do what's called the inverse of the function. So you're going to use that second function button on your calculator or the arrow up button on your smartphone calculator, and the order that you have to enter the data and put in the numbers in your calculator or smart device is going to depend on exactly which mode you're using. So I can help you with that. But we have to remember that sine and cos and tan, those are all actually functions. They're like magic black boxes. They're doing something to this angle when we put it into our calculators. So if I want to get this number out, I actually have to do this magic black box function in reverse. And that's what this piece is talking about here. This isn't saying that I'm going to do sine like 1 over like we did negative exponents. That's not what this is about. This is undoing the process that we did to theta, and we're going to undo it to the ratio instead to get our angle out. Okay, so it's undoing that function, that magic trick, that whatever this cosine or tan or sine is doing to that number, the inverse button, which is what that -1 is called, it's undoing that for us. You may also encounter on some calculators, it might be called arctan or arcsine. That's also the undoing button. And so it'll give you the angle if you input the ratio instead. So now's a good time to get to know your calculator and see how it works for all of these. It's one of the few times I am okay with you using a calculator and giving you some decimals. So try these values out, pause the video, and see if your answers match up. Note that if they don't, one of the issues may be that your calculator is in the wrong mode. So you have to be in degrees, which is that little thing, and not in either the radians or gradians mode. So if your calculator says rad or grad, sometimes it's just an R or a G versus a D or a deg. That's how you know which mode you're in. Okay, so try them out and see how it goes. Okay, so here are those answers. Just a note, you can see on my calculator here, I can change from degrees to radians and then this other gradients business, so keep it in degrees. My calculator on this computer, I have to enter the angle first and then hit my trig function button. Okay, so play around with your calculator to figure out what it does. Fortunately here I get this display. I know most calculators you're allowed, it will show you exactly what it's trying to do with the better scientific ones, so that's helpful in these cases. We take a look now working the other way. I want to know what is the angle that gives me an opposite over adjacent equal to 0.7660. So the way we set that up is you're going to take the inverse function, so the opposite of what you did to get 0.7660, and you're asking, okay, this was my output before, what would my input have been to begin with? So that's how that ends up looking when you enter it into your calculator. So here, 0.7660, that's too many sixes, but you get the idea. And I'm going to use my second function button, and there's sine. So I'll pause it again, and you can take a look and see how your answers compare. So that's if your answer should be using the inverse function to get your angles. Notice how when we're dealing with taking an angle and figuring out sine, cos, or tan, those ratios, we end up with a lot of decimals, and that's good. Keep those decimals. Don't round more than you should. Add more decimal places than you think you need when you're dealing with those ratios. When we're dealing with the actual angles, just watch what the question is asking for. Usually row to the nearest degree, maybe to 1 decimal places. All right, so putting these values to work with our SOHCAHTOA, take a look at this example. It's asking us to identify the sides of the triangle and then determine the ratio for our sine, cos, and tan of angle D. Ratio means we're leaving our answer as a fraction. Okay, and following convention, if this is angle D, I know this is side little d, this is angle E, here's that E, and if this is angle F, across from there is side F. Now, if I'm looking for my ratios, I know that sine is going to be opposite over hypotenuse, so my opposite side is going to be 5, and my hypotenuse is 12. Cos, I've got adjacent over hypotenuse. My adjacent here is 13. And my hypotenuse is still not 12. Wow, that's all wrong. Okay. I don't know how to go back with this stuff, so I'm sorry. We're just going to erase all that. So my hypotenuse is 13. Apologies that the edits are not going to be pretty on these videos. All right, so adjacent side is 12. And my hypotenuse is 13. This is probably why I should have written out what my opposite, adjacent, and hypotenuse sides were. So you could do that if you'd like. And that last one was 10. It's going to be 5 over 12. And we leave it like that because the question wants us just as the ratio, okay? Unless the question says calculate with your calculator and tells you how many decimal places, leave things as these ratios. The last part of the question is asking us to determine our angle value. And we can do that using either sine, cos, or tan. They're all going to end up giving us the same value. So dealer's choice. I'm going to write them all out. You can take your pick. Notice how this value is going to go where the D is, and it's going to be that -1 that shows up to show that it's now this opposite reverse function business going on. So you can use the inverse sine function if you want, or you can use the inverse cos function if you want, or you can use the inverse tan function if you want. All that matters is that you use the right value for the ratio for those. Any one of those should be giving you the same answer. So you should be getting 22.6 degrees. Be careful when you're entering these values into your calculator. Do your best to keep things in brackets and not round your answer. So for instance, if you had done inverse sine, keep as many of those decimal places as you can, or make friends with the answer button that's on your calculator that keeps the last number that you put in. Oh, something didn't work. Well, whatever. You know what's going on. Okay, now I got to prove that it works. So there's that, and inverse sine. So there's my 22.6. For this next example, we're going to be finding those angles G and H. It doesn't matter which one you want to start with, just pick one. All that's going to change from one to the other is which ratio we use. So if I want to start with angle G, I'm going to use cos because I've got an adjacent side and the hypotenuse. If I wanted to use H, no rule saying I can't. Well, I have the opposite side from H and the hypotenuse, so I know that I would have to use sine there. Either way, I'm going to have to use the inverse function in order to get the actual angle. So once I have one angle, I actually have two options for how I can solve for the other one. I could do the inverse function on the other angle and get it that way, or I could also do 180 minus 90 degrees minus the angle I just figured out and get that H equals 26 degrees that way. Now all that's left is to find that side length of little g over here across. And we can use any trig ratio we want, because I can do some opposite over hypotenuse business. I could do opposite over adjacent, depending which angle I want. So lots of latitude, lots of options there. I'm going to go ahead and use tan because we haven't used it yet. So make things interesting. Okay, you may also want to pick whatever ratio for sine, cos, or tan that has it, so that whatever you're looking for is in your numerator of your ratio instead of in your denominator if you're feeling a little shaky about the algebra. But we also have our little shortcut page to work with, so that's an option. So I want to get g by itself, times both sides by 6. And I know that angle G is 64, so I may as well put that in. And now this whole piece can go right into my calculator. 64 10 times 6. And we get 12.3. Okay, for the last example, I'll just put the worked out solution in the notes and you can compare. I have a feeling everyone's doing pretty good with this. Let's keep going, get this done really fast. The last part of dealing with right angle triangles is good old Pythagoras. So for any right angle triangle, that's good old a squared plus b squared equals c squared. So a and b are just called our short legs. Always dealing with right angle triangles. It doesn't matter which is a or which is b. But what does matter is c is always the hypotenuse, the longest side. If you just take a look, so some people really like this diagram and you can see what's going on here. So here's 3, here's 4, square them and you get 5 squared, and if you count the squares, it all works out. So here's a really straightforward example for us. We can make A and B either or. It doesn't matter if I say A is 14 or A is 48, but those are my short legs, and C is my hypotenuse. That's all that really matters. So in this case, X is going to be C. Set it up, do the little bit of arithmetic, and take a square root at the end. So that part is easy, but guaranteed the step everyone always forgets. Don't forget to take your square root. Another similar example, now we just have to take a look and say, okay, well, what side is X in all of this? It can be either A or B because it's not my hypotenuse, so that's all that matters. Let's say it's A. More often than not, you're going to see me take shortcuts with this and rearrange that formula. So I moved B squared over to the other side and then took the square root of the whole thing. So I usually just jump to this now that we've kind of seen it. We plug in our values. We know our arithmetic is right because this number is bigger than what's being subtracted, as we can't take the square root of a negative, and we're using a real triangle, so our numbers should be real. So if those are in the wrong order, just switch that for yourself. So after all that, we get A equals 10. So for this last example, we're being asked to solve this triangle. What that means is find out all of the side lengths and all of the angles. There's a lot of flexibility in how you can do that. Looking at this question, I've got this angle here and an opposite side, so obviously maybe something with sine and I can get the hypotenuse. Maybe if I did sine of 39, or sorry, tan of 39 and I can get the adjacent. I could jump right to figuring out what J is, doing basic arithmetic with 180 minus 90, do my ratios with sine and cos there. I don't even have to do the easy way of 180 minus 90. I could figure out this side and then do tan and figure out that angle there using trig ratios. Until I get that last side, I could do another trig ratio, or I could use Pythagoras. There's lots of different ways. It's just a matter of, what you feel like doing and what works for you. I'm going to pause the video, write up all of the, or at least one version of how it can be done, and just post that at the end so you can compare it to your notes and see what the final answers are. So lots of steps, lots of little bits here and there. Don't have to do it using tan. Lots of different ways you could have done it, but here's our solved triangle. And that's what we really care about. All right, we'll see you in the next video.